Okay, a graph is a picture that shows us how two variables change at once, and a variable is something that can be measured. So in this particular example, we're looking at the two variables involved in the relationship with regards to driving a car. So we can be measuring the time, which is our independent variable, and the time will impact the distance covered, which is our dependent variable. Okay, and that's discussed down here. And so you can see we have sort of a few different relationships here. Okay, we have a constant rate of change, okay, that is increasing. This rate of change would also be increasing, but it's non-constant because there's a curve to the line there, okay? Here we have the distance as increasing at a constant rate, then the car stops moving. So time is going by, and yet the distance is not changing, okay? And then distance is still occurring, you could say. However, the car is returning to its starting position in that little chunk of time there. So we have three different graphs on the same plane, okay? And that's sort of described here on the graphic, okay? Now consider this additional example. The number of hours you work is your independent variable. So hours will pass, and then how much you earn is dependent on how many hours you work, okay? Now this person has a pretty good gig. Even if they don't work at all, okay, they're earning $27 an hour, and then their earnings increase at a constant rate because we have a straight line, okay? And this could be the example of someone who charges a flat rate. So let's say if you want me to, I don't know, babysit your kid, okay? You got to pay me $27 just to show up at your house. And then for each additional hour I babysit, I want $3, okay? So again, just an example, but we would say that this is increasing at a constant rate. It's increasing because it's moving up to the right, and it's a constant rate because it's a straight line. Okay, in this lesson, we also want to look at trends in graph. A trend in graph is used to justify decisions and make predictions. So we have 4 different examples here, okay, 4 different scenarios. And so we're going to complete this chart here based on the graphs in the diagram. So they want to know, what is the independent variable from graph A? So I want you to look at that and think about it. Okay, and in this particular example, you'll notice that the independent variable is hours worked, which is generally plotted on the x-axis, and the dependent variable are your earnings. Okay, so the independent variable is always going to be located on the x-axis and your dependent variable on the y. So I want you to take a minute, look at these remaining graphs from part B, C, and D, okay, and see if you can distinguish which is the independent variable and which is the dependent variable. You might want to pause the video. Okay, so hopefully you went through those on your own. And again, when we are looking to distinguish between the two types, your independent variable is plotted on your x-axis and your dependent variable on your y. So earnings depend on hours worked. Amount depends on the time. Temperature depends on time. Crop yield depends on the fertilizer used. All of these things depend on the variable that was plotted on the x-axis. Okay, the second part of this example, we want to distinguish whether or not the dependent variable is either increasing or decreasing, and whether or not the rate is constant or non-constant, okay? So if it is increasing, it is moving up to the right, okay? If it's decreasing, it's moving down to the right. If it is a constant rate, it is a straight line. If it is a non-constant rate, it's a line with a curve to it. So I want you to go ahead and look at the questions, see if you can match the graph with the questions, possibly pause the video, okay, and then you can check your answer. Okay, so you can go ahead and check your answers. So which graph depicts the dependent variable increasing at a constant rate? So increasing. Both of these guys are increasing. This one's a constant rate because it's a straight line. This one is a non-constant rate because it has a bit of a curve to it. Okay, so the answer for that one would be A. Which graph depicts the dependent variable decreasing at a non-constant rate? So the only graph that depicts the dependent variable decreasing would be this graph right here. We do have this graph decreasing, but actually first it was increasing and it reached a max, okay? For the next question, which graph depicts the dependent variable increasing at a non-constant rate? And we discussed that earlier, so that one would be B. And then finally, which graph depicts the dependent variable increasing, reaching a maximum, and then decreasing? And that would be this guy right here. Okay, now this is just a little bit of a foreshadowing for the lessons that are to come. This relationship is linear. This relationship is exponential. Exponential, so we have linear growth, exponential decay, and this models a quadratic relation or a parabola. And hopefully those words are familiar to you, but if you're not too comfortable, don't worry, we're going to spend more time this unit discussing that. Okay, so let's move on. I certainly hope that the notion of rate of change or slope is something familiar to you. You've probably talked about it and explored these things in previous grades. So the slope is referred to as the rate of change, okay, how fast something changes. We also talk about slope in terms of measuring the steepness of the line. And the letter M, I know, doesn't really make sense. Slope, represented by the letter M, but not a big deal, is used to denote slope when we are trying to equate the slope. And so generally we need two ordered pairs to find the slope, and we use that equation, and don't you worry, we'll be doing some examples together. Before we do that though, I want to look at the different scenarios for slope. So here, okay, if we have a horizontal line, that means the rate of change is 0. So we talked about the independent variable being plotted on the x-axis. Okay, things are moving and shaking in the independent variable. Okay, so we are moving along here to the right. However, the dependent variable, or the y value plotted on the y-axis, is not changing. Okay, and here's an example that I kind of have in the bubble here. So this is what the graph would look like. This is what the table of values would look like. Again, changes in the independent variable, but this y column here is not changing. Now let's look at the little scenario. Okay, the independent variable has no effect on the dependent variable. Think of standing still. No matter how much time goes by, so let's say these are seconds, if you're standing still, the distance that you cover is not going to change. So if I am 5 meters from the building and I don't move as time goes by, I will still be 5 meters from the building. So this is one of the scenarios we can look at for slope. You could have 0 rate of change, which is represented by a horizontal line on a graph, and no change in the dependent variable. Okay, we saw an example of this earlier. We could have a constant rate of change in which, okay, we have a graph represented by a straight line, and every change in the independent variable produces an equal change in the dependent variable. So this column is increasing by 12 every single time, okay? It's a constant rate of change. So here the example that I have, because we want to make sure we understand this graphically, that we understand what this looks like in a table of values, and then we can apply a real life application, okay? And the easiest example to think of here is a minimum wage or an hourly wage, okay? If you don't work, you make money. If you work 1 hour, $12. 2 hours, $24. For each additional hour you work, you're earning an equal amount of money, okay? And then the last example that we look at in terms of slope and rate of change is a non-constant rate of change, okay? So here we have changes in the independent variable, but they don't produce the exact same incremental changes in the dependent variable, okay? So it would look like this in terms of a graph, which we saw on the previous page. This is what the table of values would look like. Again, here, okay, the y value changed by 1, but then it changed by 2, and then it changed by 4. So that is a non-constant rate of change. Over here, The independent variable has a changing effect on the dependent variable. If we think about cell division, for those of you that are interested in biology, okay? So we start with one cell, then after an hour passes, it's split into two, then each of those two cells split again into four, and then each of those four cells split into eight, okay? And so on. So we don't have the same incremental change every time. So those would be your three scenarios. You could have no change, which is represented by a horizontal line, a constant rate of change, which shows growth, or a non-constant rate of change with a curve. All right, let's jump into a real life example. The population growth over time, measured in seconds, of a particular bacteria is displayed by the following graph. So in part A, they want you to describe the general trend. What I'm looking for there is it increasing or decreasing? And is it constant or non-constant? So have a look and try to answer. Maybe pause the video before the solution is revealed to see if you would have gotten it correct. Okay, so it is increasing because it's moving up to the right, but it is increasing at a non-constant rate. Ooh, I should probably throw a little one of those in there. Okay, that's better. At a non-constant rate because there is a curve to the graph. It is not a straight line. Okay? Part B, what is the vertical intercept? Or in other words, where does the graph start on the y-axis? So have a look. Make a prediction before I reveal the solution, just to see if you're on track. Okay, so this graph is kind of difficult to read, okay? But if this is the 10,000 mark, this would be about 5,000, and I would say that this is 1,000, which actually is funny because I forgot a zero in here. Woo! All right, I would say that's about 1,000, okay? Now they want to know, with regards to this particular graph, what does that represent? So again, have a look, make a prediction before I reveal the answer. Okay? That vertical intercept represents the number of bacteria at the beginning, okay? So let's say at the beginning of the experiment or at the beginning of the growth period. So we are not starting with 0 bacteria. We are starting with 1,000 samples or units of bacteria, okay? And then we can see it grows at a non-constant rate. How many bacteria after 2 minutes? Okay, so we have to be careful because this particular graph is being measured in seconds. Okay, and so the 2-minute mark would be 120 seconds, and I want you to try to read that off the graph. Okay, try to answer without looking at the answer in the video. You might want to pause. Okay, you can see I made a little note here. So after 2 minutes or 120 seconds, it looks like there are 10,000 units of bacteria. Okay, and finally, does the number of bacteria double in the next 2 minutes? Okay. So I want you to try to answer that. Yes or no, and explain why. Okay, and so to answer that question, okay, if at the 2-minute mark or 120 seconds, we only had 10,000 units of bacteria, okay, the next 2-minute mark, which would be 240 seconds, you'll notice there's so much bacteria, it can't be recorded on the chart. And so the answer is no. It does not double in the next 2 minutes. It more than doubles because we have far surpassed the 20,000 mark. Okay? So this is just essentially an exercise in reading a graph. Okay, the next example, okay, we're given a table here. So previously we were asked to answer questions about a graph. Now we're being asked to answer questions from a table of values. It's asking us what are the variables? And again, the variables are the things being measured. Okay, so have a look. Pause the video. You might possibly want to try to answer on your own. Okay, and it might seem like I cheated, but I didn't. This question's just that straightforward. What's being measured here? Number of Timbits in this column and the calories in this column, okay? State the units for the rate of change, okay? So whenever they're asking for the units for the rate of change, they wanna know how are we measuring the dependent variable? How are we measuring the independent variable, okay? And if that kind of throws you off, Think of it this way. A perfect example of rate of change that you see every single day when you're in transit is kilometers per hour. So we just have to distinguish, is this timbits per calorie or calories per timbit? And I want you to think about that. Okay, it is calories per timbit, and I'll talk more about that in a minute. Now they want us to find the slope, okay, or the average rate of change. You'll notice here, okay, every time we increase in the y column or the dependent variable, we're increasing by the same amount, okay? This might ring a bell. We have equal first differences. But I could use any combination of these numbers to find the average rate of change. So let's say, does that work? There we go. Okay, we know that m denotes slope. Let's make sure my pencil works here. Okay, let's say I want to use these pieces of data and these pieces of data. Okay, remember when we find slope, we subtract our y's on the top. So 60 minus 0 over 1 minus 0. Okay, some nice easy math here. 60 minus 0 is 60. 1 minus 0 is 1. So we have 60 over 1, which is just 60. 60 calories per timbit. Okay? So again, when we find the slope or the average rate of change, the units are going to follow the same sort of order that we used in the formula. We subtract our y's on the top, and so we used the units for our y's to come first. Okay, calories per timbit, because the per you could think of as your division line, and these are the units of the independent variable. Okay, similar question down here. In number 3, it says examine the table below. What are the variables? And here, they don't need us to find the rate of change. They just want us to state the units. So using the example that we did above, that's very similar. I want you to go ahead and try that question. Maybe pause the video and then return to make sure you did it correctly. Okay, so what is being measured here? Minutes and number of texts. And if we were to find the rate of change, again, they didn't ask us for the rate of change. They just wanted the units, okay? So it would be texts per minute. Now, it's funny that I said they didn't actually ask us for the rate of change, because on the next page in part C, they do want us to find the rate of change. So we're going to use the same strategy we used earlier, where we pick any 2 ordered pairs. And again, each set of values in the table of values represent an ordered pair, okay? So I don't want to keep copying from one page to the other. I'm just going to get these down. So let's say I were to use these guys. Woo! So we have the ordered pair 20, 160, okay? And 15 and 120. Okay, and I am going to use my slope formula. I hope you can see this here. Minus the y's on the top and the x's on the bottom. Okay, here are my y's. So I'm going 120 minus 160 over 15 minus 20. Okay, here we have a negative 40 over a negative 5, running out of room there. And that is equal to 8. And we're going to include the unit. So if we go back to here, that's 8 texts per minute. Okay? And if you would like me to go through this example with you in more detail, more slowly, I'm happy to do that. Just send me a message on Etsy. Okay, one more question. Here, again, they want to know what are the variables. So go ahead and actually I'm going to ask you to try all these questions, A, B, C, based on this graph. And you might want to pause the video and then come back and verify your answers. Okay, so I already got the ball rolling here. In this one, okay, what is being measured, or what are the variables? Distance and time, because those are the titles of my X and Y axis. What are the units for the rate of change? Remember, the units for the dependent or the variable in the Y axis come first. So we would have meters per second. okay? Now they want us to find the rate of change, and they actually gave us 2 ordered pairs to use, okay? So I'm gonna go ahead and use that slope formula, okay? I'm gonna minus my y's, so 32 minus 8 on the top and minus my x's on the bottom. Now, because I started with 32, I must start with 4. Okay, that works out to be 12 meters per second. Okay, there is your assigned homework for this particular section. And again, you're always welcome to message me on Etsby with questions.